to have one big three-phase generator and one big single-phase generator, and there was no way to put it. It wouldn't fit anywhere here. So Theo came to me and said, what do I do with this? I said, we'll have to go DC hydraulics and a small AC single phase. So basically we design DC generator here, 24 volts, 200 amps. Then we have compressors running of the engine. We then have combi system here that does all the air conditioning, refrigeration, desalination and deck wash, all in one, in that box. That okay. That is then run. This hydraulic pump is driven by this splitter, where we have the compressor, the pump, and this is a separate pump for steering. So all in one. So none of this extra. There was another box for steering, and there was just so much stuff that we couldn't put in. So the hydraulic system works together with the hydraulic system of the generator, right? So that generator is also Yanmar, and we have a hydraulic pump, and this is the combi motor comes generator. So basically that motor will produce 240 volts, 50 hertz, 4 kilowatts. So we've solved all the problems of the size. Now what it runs, obviously the engine provides the energy of all the hydraulics, all the engine compressor, and also provides plenty of DC power. Then Theo can run all of these things. So for example, he needs to have one electrically driven pump, which can be driven from the bank batteries through inverter. That's the only one which we are running for it. There's another electric motor which can be run from the inverter, and the rest of it, it's run hydraulically. So for example, here, this system had a big motor like that. It's replaced by tiny motor like the two systems, 1 and 2, run hydraulically. Then we have another hydraulic pump. There's another hydraulic pump over there with hydraulic motor. Okay. Now, the reason for this is purely a survey requirement, isn't it? The reason for the pump is the survey requirement here.
That's for that pump there. That's one of the bilge pumps.
Bilge pump,
for regulations, you've got to have two bilge pumps, and they have to have different power sources in case one. Actually, I've got about 4 bilge pumps the way this is set up.
Yeah. Okay. So this is the requirement. Otherwise, we would have replaced them with the DC. But that's the requirement of the survey. Now you can have a look. For example, when we got rid of the weight, there was a huge motor bigger than this, right? In that compressor. That motor there is the hydraulic motor.
They're tiny.
The tiny blue one.
Very tiny motors.
So because of that, we can fit all the equipment he wanted to use here.
It's the same motor on this one here. See, it's exactly the same, driving that compressor. Small motor again.
And these motors have much more power than the electric motor, and we can also adjust the speed.
Yeah, yes, easy to make the speed variable.
Now, the hydraulic power from the engine and from the generator will be fed into a Rexroth distribution box. It will come here, right? Now from here are the outlets. So we have not yet dedicated them, but there will be one to the combi, right? One to the winch, another one to the pump the diving pumps, another to the diving pumps, another one to the hydraulic pump, and so on. It will be all driven from these sections. So 1, 2, 3, 4, 5, 6, 7. We have 7 sections, correct? And we will have, I can't remember how many things we have. We eliminated some and added some. For example, here we got, let's say, Theo wants to do desalination, so he'll leave it like this, right? So the thing will go through the tubes, desalination tubes, and the water will be dumped into the water tank. When he stops and wants to clean the boat, he will take the lever like that, and outside he's got an outlet and have a gun and do a high pressure decoche. He can set up on computer the pressure like 55, 60 bars, that automatically keeps the pressure. So that's what this is for. There is the water coming in from outside into the system, and there is the driver for the electric motors. These heat exchangers are all cleanable, so you unscrew the screws and take like a brush for gun and clean them after a year or 2 years in operation. This is the booster. That booster converts the power which comes from shore power into 400 volts. The power goes to the motor, which you can't see here, and drives it from shore.
Oh, beauty! So when I plug in the shore power, I can use all this system.
Yeah, that's right. Yeah.
Just what
You can
15 amps, 10 amps?
Yeah. There's no more than 50. I think 15 or 17 amps you can take out of it. Yeah.
What if it was only 10 amps?
No, it doesn't matter.
Doesn't matter.
Doesn't matter. The system. What I found out from experience, because we have a soft start, we took out of a 15 amp circuit breakers on Marina. We squeeze out 25 amps because it grows very, very slowly.
I see.
And by the time you freeze the freezers, the demand drops and then the current drops. So the circuit breaker would get hot and pop out. But when you're actually running it with a soft start, the circuit breaker will tolerate higher current for maybe half an hour. And then after half an hour, as you compress the gas, then of course there's less pressure, so the power goes below 15 amps and then go below 10 and you're fine. And then you're air conditioning. So it looks...
What a ripper!
Yeah, that's right. So that's how it works. Now this part here is the inverter. So when you're running hydraulic system here through this outlet, it runs the compressors or runs the desalination or combination of those two, but at the same time spins the motor. And the motor then becomes generator. So the power from the motor goes in here, right? Control it, and the power goes into the main switchboard. Now I think we have another one somewhere here, another one there. So we have two. Now, when the main engine stops, right? We will need power. So let's say you are anchoring someplace and there is no shore power. So you start up a generator. The generator, it's a hydraulic pump, which again runs the combi and all of the things here. Everything you've got, you can pump, you can do the compressors. You have to share the power, but you have plenty. You can run all those toys and all of this without any hassle. You'll still produce 240 volts there. Right? Now, so you have 240 volts, 4 kilowatts one end, and then there is a basically it's almost the same motor as combi that produces the power to here, and you'll have two different powers. Let's say you can call them left and right. So you have a 4 kilowatts on one end and 4 kilowatts. So you can have a double power points, right? But each 4 kilowatt comes from a different source. One comes from, you can't join them together, right? But you have them separate. So you, for example, you have a dual thing. So you connect one here and one there, but one comes from here, another one comes from there.
There, I see.
So basically, then you can have them like whenever you want to have those outlets, you have them there. Left one is from here, but they both will give you the power. This one will give you power from combi, that one will give you power from the...
Yeah, I see.
So that's how it works.
Actually, both systems are basically, all the generator does,
Yeah.
it just replaces the main engine system.
Exactly.
It's just a smaller unit.
The only difference is that on the output here, and here and there is a non-return valve. So when they work together, they can work together if you like, but there's no need, right?
There's no
But
need.
if, for example, you switch this off and turn it on, there is a non-return valve. So the oil goes here to the distributor, ends up here, but it's blocked, so it doesn't do anything here.
I see.
Vice versa, when you fire up this, there's a non-return valve there, so it goes to the system, comes to here and it stops, because there's no way this is not turning. So when this is not turning, when this is turning and that's not turning, then there's a non-returning valve. When this is turning and that's not turning, then non-return valve will stop here. If you for some reason needed to fire a boat, which I don't know why, but let's say something failed, the pump failed,
Yeah.
well, that can happen. I mean,
Yeah.
these things are very, very reliable, but things can happen.
Yeah,
So it doesn't matter, you will switch it off there,
Yeah.
fire up the generator, and the generator will do the same job. So then you have to go and fix up the pump.
Ah, sort of a backup.
Yeah, it's like a backup, yeah.
Yeah, it's a backup.
Yeah. And
Fail safe.
yes, and also those things I didn't supply you with all the things because there's so much to send you. So I got still a lot of stuff at home.
Okay.
There will be electronic boxes, little ones, which will fit somewhere here. They connect into these things, and then you can control you can adjust the speed. You can turn them on and off.
I see.
Lots of it.
I see.
So when you come here, for example, you will have something here to start up the engine, right? And that's it. Now here we got we have an inverter here. I think from memory, this is a booster, and this is the power supply for sure. So when you
Battery charger.
Battery charger, yes.
That's the battery charger.
Yes. Yeah. So that's basically it. Now the engine starts 24 volt. 24 volt, isn't it?
24 volt above ground earth.
But that's right. And here are the batteries, which I supplied here.
Yeah.
You don't- So here are the batteries that will power them. Ah, yeah, I know. Another trick is here, because this generator, it's 12 volt. The alternator here is 12 volt.
Yeah.
So when this stops, we will not have 24 volts, right? When this stops, you will.
Well, that's 24 volt.
Yeah, I know, but this is 12.
That's right.
So instead of changing the alternator, which is difficult,
Yeah, yeah.
we have a booster.
Oh, I see.
It comes from here to there,
There.
and then it will go into the batteries.
I
So,
see.
so you'll have your batteries charged from this little thing,
Okay.
and if it's not enough, we'll make another one. That's not.
Well, two of the batteries, I believe, hooked up, giving 24
And
volts,
one is this.
and that one's a 12 volt.
That's right, yeah.
That one's for the auxiliary.
So we can charge that to here, right?
Yeah.
Directly.
Yeah, I
And
see.
Recharge, because that 24 volt will go to the batteries upstairs.
Okay.
Because you need to get the wires from the batteries upstairs where you got the. I
Yeah.
found some batteries for you, by the way, but there's no need to buy them now because
Yeah, that's right.
there's no point. So that will charge your house battery. So when this is running, it will keep this battery fresh,
Yep.
and it will keep the batteries fresh. And
I
that
see.
gives you, I think from memory, enough to run the pumps and all that sort of stuff. And all the lights are, anyway, they are.
Well, they're all LED.
So there's no.
Yeah, yeah. Yeah, I've had the Hella wrapped down,
Yeah.
and he's left a lot of lights for sample, and I'm
Yeah.
putting all Hella.
Yeah.
They've got multi-voltage, I think, from 9 to about 33 volts.
So you have to run, this is about 6 or 7 amps each, it's nothing, right? Then you have got lights, they'll be lucky to draw 5-6 amps. And then, what else is there? That's about it.
Hot water service behind you,
But this is what
coming off the main engine,
engine, so it's,
and also coming off the auxiliary. See, it's got double inlets and outlets, see that?
yeah, that's
And
right.
beside it, the red one there, that's the fresh water pressure
Water
pump,
pressure pump, yeah.
which has a bladder inside it, so you don't get that hunting, that chattering.
Yeah, that's right. So that's that. So we need to get the guys here and to connect all this up because that's quite a lot of piping.
You like the way I
Yeah,
got the
good.
supported?
I was going to comment, very
The
good.
rubber things on that, eh?
I'm normal, don't worry.
Jesus. Oh, mate. You've got to give it to the Dutch.
You give it to the Dutch, yeah.
Unbelievable. That's it.
Well, I said to you, because I'm not Dutch, I'm not much, sorry about that, my friend.
Unbelievable engineering.
Yes.
Yeah, it's in the gene pool.
It's a gene pool, yeah.
I would have made a great pigeon.
Yes.
I would have been winning all the prizes.
Sure, that's right.
You know?
So there you go.